All right. Well, welcome everyone to the first installment of this 24 Hours of Pass 2016 Summit Preview. We're excited you could join us today for David Klee's session, The Complete Primer to SQL Server Virtualization. This 24 Hours of Pass event consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. This session will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hoursofpass.com for all session links. My name is Aaron Nelson. I'm the moderator today, and I'm the leader of the PowerShell virtual chapter of Pass. I have a few introductory slides before I hand the reins over to David. If you require technical assistance, please type your question in the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I will read the questions aloud to the speaker. You're able to zoom in the presentation content by using the zoom button located at the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us. Please take a moment to complete it. It will appear in your web browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Idera, and Attunity. In addition, I'd also like to thank the supporting sponsors of this event, SQL Sentry and Hewlett-Packard Enterprise. Hewlett-Packard Enterprise and Microsoft combine their respective strengths to deliver innovative technologies that advance your business. HPE's integrated solutions, services, and support help amplify the speed and effectiveness of your business, grow your competitive edge, and deliver tangible business results. Check out their handout in the pane of your control panel for more information. This staging of the 24 Hours of Pass would not be possible without their generous support, and they are the reason this event is available free of charge. Make sure you explore everything Pass has on offer for data professionals. You can join local user groups around the world, special interest groups, find online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. Next, I'd like to bring your attention to the upcoming Pass Summit, taking place in Seattle, Washington from October 25th to the 28th. Pass Summit 2016 features over 200 sessions with world-class data experts. It's the perfect place to make networking with experts and peers, and you can meet Microsoft engineering team behind SQL Server 2016. Save $200 on registration by using the exclusive discount code 24HOP200 before the end of the day, Sunday, September 18th. To find out more, visit passsummit.com. Real quick about me, I'm your moderator, Aaron Nelson. I'm the leader of the PowerShell virtual chapter of Pass. You can find us at powershell.sqlpass.org. We do have a meeting next Tuesday, and if you go to sqlps.io/n3, you can register for that meeting today. And finally, I'd like to introduce you to today's speaker, David Klee. He is the founder and chief architect of Heraflux Technologies. His areas of expertise are virtualization and performance, data center architecture, and risk mitigation through high availability and disaster recovery.
Hi everybody. Just want to say I am a efficiency and stats geek as well. Well, just kind of an all-around geek, I guess. So this is the complete primer to SQL Server Virtualization Preview Edition. We're going to talk about resource scheduling inside the virtualization layer. So thanks, Aaron, for getting us rolling. Okay, what we're going to do today, we're going to start by talking about really just what is virtualization from an infrastructure perspective. It's resources and queues. And then we're going to talk about how to handle the CPU scheduling of these virtual machines and how to make sure you get them right. Now, this isn't just on-prem virtualization. This is anything infrastructure as a service in the public cloud as well. We're going to talk about what happens inside the hypervisor itself. We're going to talk about what happens if you get it right with CPU scheduling and maintaining performance, and what happens if you get it wrong. And we're also going to talk about a number of individual layers that you can actually go through and tune properly. Okay, so first of all, what is virtualization to me? To me personally, virtualization is not just a bunch of computers somewhere, you know. And you look at public cloud and there is no cloud. I mean, it's just somebody else's computer with some automation on top of it. Functionally, what it is a collection of compute resources. So in this case, you know, what a friend of mine calls the 4 IT food groups: CPU, memory, network, disk. You've got a fixed and finite amount of these that you have at your disposal. You throw in virtualization or cloud, and now you can start to slice and dice and carve up these different resources to get what you need. Now, functionally, the hypervisor layer adds queues to go get access to all these physical CPU, memory, network, and disk resources. What happens here is that you have a VM that submits something into what it thinks is the hardware. That hardware request from inside the OS goes inside one of these queues. It sits and waits for the hypervisor to schedule it properly, and then it actually gets executed. We're going to focus on CPU scheduling because that's one of the biggest and most silent performance killers that you're ever going to find with virtualization. Now, our goal is minimizing these waits. Resource limits that we've been dealing with for years, these things are easy to work around. It's things such as, you know, I've got 128 gigs of RAM, I'm 90% consumed. We can measure this. We've seen this for years. The challenge here is measuring what happens inside the queues. These things are silent. These are quiet. You don't see these in any error log. It's even really hard to detect a lot of this inside the operating system of the guest itself because it just sees the end result of this entire chain of processes happening. Every millisecond spent in these queues is time lost from that VM actually getting to run what it needs, which is not good because if we've done things wrong or if there's a lot of background activity or if they're not getting processed properly, it's going to slow it down. And again, you can't see it from inside the VM most of the time. Every single thing in that virtual machine must be scheduled into these queues, and it's really interesting to figure out here that even idle resources can slow you down. And the hypervisor will actually go through and detect, you know, if something's really busy or something's really idle. It can actually have things jump around in the queues. So it's not always first in, first out, which gets really fascinating real fast. Okay, for those of you that haven't seen this before, this is a computer motherboard. This is essentially what's underneath every bit of computing out there on the planet, something similar to this. That is a CPU socket. These are memory slots. Note, in this case, we have 4 CPU sockets and a whole bunch of RAM. We're going to talk more about this. Now, back in the day, long time ago, we had CPU and we had RAM. And we had a single path for the CPU to get to RAM. And, you know, when you had a CPU and 16 gig of RAM, that's not so bad. But on these big enterprise servers, what they found was that over time, the interconnect between a lot of CPUs and a lot of RAM started to become a problem. So AMD pioneered it, Intel perfected it. They came up with this concept called non-uniform memory access. And what they ended up doing was they actually put the memory controllers on each of the CPUs and put a subset of the overall memory very, very close in proximity to each one of these CPU sockets. Fun part there is that physics says that the memory footprint, it's actually a lot closer to go get access to memory that's closer to you on the motherboard. It's faster. That's that same motherboard. If that CPU wanted to access the memory in that slot, no big deal. It's quick. It's right there. I mean, it doesn't have that far to travel. However, if that same CPU wanted to access that RAM, that is up to 3 times performance penalty to go get it. You know, if you look, it's a lot further distance. You know, electrons, they travel fast. We're still talking nanoseconds, but it's still slower. It's up to 3 times longer to go get that, which is tough. You know, in the compute world, that's forever. So what they decided to do was to extend this proximity into these machines. The fun part here is if you can pin a VM to fit on one of these NUMA nodes, then it's going to go faster because all the memory is right there local to the CPUs. Now, how does this matter when it comes to the virtual machine, when it comes to the cloud platform? We're going to talk in depth about that. Now, you take that motherboard. Right now, we're at the physical server. You add virtualization on top of it, and things get really interesting real fast. And this is a very common challenge outside of the physical world. When you start to look at the virtual world, a lot of VM admins are very comfortable with virtualizing these things, but there are a lot of things in this particular aspect that they get wrong. And I spend a lot of time day to day handling these kind of challenges. Okay. Inside the VM, it's kind of like a physical computer from at least the operating system perspective. We have emulation for everything that the VM has. We've got CPUs, we've got drives, we've got RAM. I mean, I can even add a virtual optical drive to put a virtual CD-ROM in. I've also got virtual network adapters. Now, one of the things here, I have virtual disk controller. If you come to my session, we'll talk a lot more in depth about why those things matter as well. But for now, we're going to focus on virtual CPUs because these are very easy to go correct, and they're a big challenge to go get right. So first and foremost, you got a lot of options here. How many CPUs do you actually need on a given VM? Well, we're the DBA. We want as many as we can get, right? The challenge here is just like putting a parachute on a moving car, too many of these things can slow down a VM as much as having too few. It sounds bizarre, but I had one instance just a little while back. A friend of mine called up actually and said, hey, we need some help. We got this VM. It's slow. We've been adding CPUs to it, and it doesn't work. It's just slower and slower and slower. It's like, okay, well, stop. Let's take a look at this. So we did some performance profiling. They had 32 CPUs on there, and I looked at them and said, this is a big SQL server, pretty active. And I said, take that 32 and knock it down to 4. Well, he looked at me like I was crazy. And I said, trust me, let's test this. There's never any assumption with any of this, but let's test and see what it's going to do. And he wouldn't do it. And I finally had to bribe him with red meat. And finally he said, okay, if I get this, and if I do this and it makes things better, then I'll buy you a big steak. If it doesn't work, then you owe me a big steak. Let's go, okay. So we went from 32 CPUs to 4. We got 2.5 times the performance improvement. A big deal. That's a big deal. And what it was is they had too many assigned. Well, it acts kind of like, just like I said, a parachute on a moving car. Just not good. It's not where you want to be. The question here is, how many is the right way to do it? How many do you actually need? Well, it all comes down to baselining and benchmarking your environment. So this is an actual graph from a customer of mine. They had 16 CPUs. When they were going to virtualize it, they wanted to figure out, okay, well, do we stay at 16? Do we add more? And if you take a look at this, this is an average over 1 month of business day activity for them. You can see they did index maintenance right after midnight. They did backups after that. They did a bit of ETL processing at about 8 a.m. They were busy in the afternoon, and they had some stuff running in the evening. Okay. Well, we were going to take a real good look at virtualizing this, and I said, I don't have enough information. And why is that? and the problem here is this is the kind of view that a lot of these enterprise systems give you. You have to dig in and really drill in to see more of what's going on. For example, we got 16 CPUs here. This top peak here is about 33-34% consumed. Okay, well, what if that's 4 CPUs that were just pegged at 100% and everything else was pretty idle? Or what if it's properly balanced? You don't know from looking at this. So now let's take the same graph and let's expand out the individual CPUs. Okay, so this is what we did. And you take a good look at it, and now we can find that it's a little imbalanced with this process that runs here after midnight. And at 3 a.m. you can see we've got about 2 or 3 threads that run a little busy. But the rest of the day, we're fairly well balanced. So this process that run after midnight, that was basically index maintenance. And we're a little busier there. But we're not maxing anything out. We're not doing anything crazy. So in this case, we're at 16 CPUs currently. They wanted to figure out how many more to add, and I told them, well, we need to add -8. I wanted to start testing this at 8 CPUs, and we did some testing. We actually found that that balanced out pretty well. We didn't max anything out again. We were fairly close with that one thread, but they had some headroom in there, and that's where we ended up going with the production machine. Now, not all servers are like this. This is where it's always variable, but understanding your workload and the performance characteristics are absolutely key. So this is one of their other systems. They wanted to virtualize this. And you can see we've got a different performance profile here. They're busy all the way in the evening until right around the start of the business day. And then it gets pretty quiet. And then they kick in, late afternoon, and some things run late evening, and then overnight we start again. They wanted to virtualize this. Again, no problem. But we looked at the performance on here, and turns out the stuff that's running in the evening, it's not something as simple as an index job. That was a full-bore ETL package that a lot of their data warehousing depended on. So we looked, and we were fairly close. Now, we look at it again, and you can see that we are maxed out briefly right after midnight. But then we have a couple of threads here that seem a lot higher than the others. We've got a NUMA imbalance here. So this physical server, when we virtualized this, we kept it at 16 CPUs, but we actually went in and found that their ETL processing here was it was mostly serial, and as a result, SSIS was not parallelizing it well. So we virtualized this, but we also had them go in and clean up that process. So it's one of those, you got to get pretty granular with this. You got to go see what do you actually need from a business standpoint, and not just looking at running averages with low granularity. But it's interesting. When you hit the VM, the physical server, I've got X number of sockets, I've got X number of cores. Well, you can actually go construct virtual machines that can go balance and match what that physical server has, and you can size the VM to fit properly inside that physical machine. At the VM level, doesn't matter the hypervisor, you can go in and you can say, this VM, if I've got 16 CPUs, well, maybe it fits best if I do 2 virtual sockets, each with 8 virtual core. Now you can enable hot add here, but most of the hypervisors out there will actually disable virtual NUMA from being extended into the VM if you enable that, which is, if you need that burst capability, okay, but you might be taking a 20, 30, 40% performance hit just by checking that box. And again, most VM admins don't know that, so keep that in mind. So the CPU configuration here really matters. I want to fit the VM inside the smallest physical footprint that we can possibly get. If it fits inside one NUMA node, great. Size it properly, make sure it'll fit. If it exceeds a NUMA node, split it and then test and test and test and test. For example, that same example, 16 CPUs. Well, what's better? 4 sockets by 4 cores? 2 by 8, 8 by 2, 1 by 16, and in some configurations, if you set it to 16 virtual sockets by 1 virtual core each, the hypervisor will actually automatically present NUMA into the VM. But you don't know. You got to go test it. So here's that same motherboard again. I always go back to this image. if the VM fits there, life is good. If it doesn't, let's balance this. What if we need to fit 1, 2? What if it works better if we split it into fitting all 4? And it really all depends. It depends on your background activity. It depends on the parallelism and the workload characteristics of your server. It depends on the physical motherboard. And it also just depends on how intense that workload really is. I always say stress test it with whatever environment you've got. It really all depends. Now, hopefully you've got something like distributed replay or some sort of actual workload replay mechanism that you can go test these different configurations. If you don't, this is with HammerDB. Now, it's a synthetic benchmark. It's not perfect, but it works fairly well to go prove a point. In this case, this is the same exact HammerDB workload done with different workload intensities with different virtual CPU configurations. And you can see the dark blue line is a 4x4, the light blue line is a 2x8, and the yellow line is an 8x2. And the physical server that this was running on was a 4-socket by 10 virtual core physical machine. And what you see here is that on average, the 2x8 comes in last until the workload is at a point where it's actually more efficient for the hypervisor and Windows and SQL Server to start balancing only 2 NUMA nodes instead of 4 or 8. And you can see the performance characteristics just grow as the workload intensity goes up. So you have to go test this stuff and figure it out. But the good thing is, hopefully you've got the means to go do this, distributed replay, whatever, and it helps. It helps a lot. Now again, the workload sizing is key. You can go fit this inside one physical machine. Now, if you don't know the CPUs that you've got, Glenberry's got a lot of really good write-ups for how to go identify this. CPU sockets and cores, if you run CPU Z, free utility inside a VM, it'll actually tell you the make and model of the CPUs. That information is passed through the hypervisor into the guest. You can do a quick, bingle search of your choice and go see, based on that CPU, you can get a really good idea of what the physical configuration is like of your hardware. Now, take that, go to your server admins. Hopefully they'll tell you. I really hope they do. And you can start to figure this out and balance it properly. In this case, the 1x10 will fit into the 1x12 CPU socket, no problem. If it's a 2x8, it's not going to fit too well. So in this case, you chop it up, 2x8, the 8 fits inside the 12 pretty comfortably. And again, not all workloads are like this. You got to go test it. There might be a lot of background activity or a lot of really big VMs running there. So you got to go check it. You got to go test it. Fun part here is you can actually validate this from inside SQL Server. You can go see inside the instance properties, you can actually go validate the different NUMA nodes that you've got. Now, please don't do processor affinity unless you really need to. I want to manage all these different resource layers from the hypervisor as much as I can, because otherwise you're now fighting with the VM admins for resource allocations and all that kind of stuff. It gets pretty interesting there real fast. Now, the NUMA layers, when a VM admin tells you it's going to fit just fine, you have to not only worry about the physical server, you have to worry about the hypervisor, and you have to worry about Windows, and you have to worry about SQL Server. There are times where a very widely parallelized workload might work great on a physical server, but Windows might struggle to balance a NUMA load there, and SQL Server may reserve the right to do some funny stuff there. I mean, they've got 22 core chips out now. That's huge. That's a lot of NUMA management. Now again, the time stuck in the scheduling queue gets interesting. The fun part here is a lot of these hypervisors actually expose a lot of this information, which is great. Hyper-V calls the time stuck in the queue wait time per dispatch. VMware calls it ready time. They're functionally the same exact thing. It's time spent in the queue, which is time not spent running, and you can go measure this. Now, if you measure it, it's pretty cool. This is a screenshot from a VMware environment, and all it is is the time spent in the scheduling queue per virtual CPU per polling interval. Now on Hyper-V, the polling interval is whatever you set it up to be within SCOM, or perfmon on the host, whatever you need. On VMware, it's a 20-second polling interval unless you've gone through and hacked a couple of things, which I don't recommend. In this case, the results here is the number of milliseconds spent, which in this case it's that latest column right there, divided by 20,000 milliseconds in the polling interval, or in Hyper-V, whatever you've set yours to, times 100%. So now let's do a little bit of math here. Let's pick the worst thing in the last hour, which on this screen is 117. So if I go 117 divided by 20,000 times 100%, that is 0.585% performance overhead. That's not bad. That's really not bad. In fact, that's pretty darn good. I mean, you can see it, and if you're really, really good, you might be able to measure it, but you certainly won't notice that. The fun part here is this particular screenshot was taken from an environment that had 2.5 virtual CPUs assigned and allocated for every one physical core that was in that environment. It's pretty good. If you balance these things properly, the amount of background activity isn't that bad. However, the time spent in that queue can really change a lot of things, and it's not good if it's done wrong. And if it's not managed properly, then it's one of the biggest silent performance killers out there. Again, most VM admins aren't watching this, and in fact, the hypervisors out there generally don't have any good alerts for this kind of stuff either. This is a screenshot of what happens when you get it wrong. This was an environment where they go, I have 16 physical cores, so I'm going to create one virtual socket by 16 virtual cores. No problem. Well, it was actually two physical sockets, each with 8 cores. It wasn't balanced properly, and what you find was that half of the cores had roughly a 15% performance penalty on it, whereas the other ones were running just fine. This one was very widely parallelized with a big reporting server, so functionally the entire server was taking about a 25% performance hit. The customer wanted to know what was going on, called up, took one look at it, and said, well, let's take this VM and let's resize it. Let's keep it at 16 CPUs for now, but let's set this to 2 sockets by 8 virtual cores. And we did that, turned it back on, and the problem magically went away. It's because the VM was now fitting properly inside the virtual layers. Okay, why is all of this a really, really big challenge? Well, think about this. Long time ago, all of your in-guest, so in this case, operating system level timekeeping, were done through this thing in the CPUs called the clock tick. 64 times a second, there's this thing inside every CPU called it's basically like a metronome. It's just tick, 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 tick. Essentially, that is how all of these operating systems, including the hardware, keep track of what time it is. So Windows itself will keep track of things like CPU consumption, disk latency, and it does all of this on the amount of stuff consumed on a 64th of a second divided by that time slice. Works great. It's that foundation that everything is dependent on for years because it's always predictable. But what happens if your CPUs are now emulated because of the virtualization or the cloud layer, and you get an imbalance like this where some of your cores, in this case, are now having 15% of that time slice that is irregularly presented and potentially missing at the end of an hour? Well, that makes the basis for every one of these performance counters to potentially be skewed. I don't want to say it's wrong, but it certainly can be skewed, especially if the scheduling queues are higher and higher and higher. That's not good, because this basically means that every performance monitoring tool that we've ever depended on in our entire careers could be wrong. And this is why it is so critical that you get access into the hypervisor. You don't need full access, just read-only access. That's all you need. If you can get access into that, you can actually see the scheduling impact. And while you might not be able to calculate the impact to the in-guests metrics, you can certainly say that in this time window we had a very bad problem with wait time per dispatch, or some of the other metrics in there. And you can actually say, well, this time sample, these metrics might be skewed because our scheduling delays were a lot higher than we actually expected. Now, as a DBA, you have two settings that will help you immensely with all of this. You have cost threshold for parallelism, and you have max degree of parallelism. All this comes full circle. So we know what the physical server topology is like. We know we have X number of sockets, we have X number of cores. If the VM is balanced properly, we can either fit inside one or we can span multiple ones. Fun part here is you now have the threshold at which to actually go set where SQL Server starts parallelizing. And I don't want to tell you a number here, but there are very good ways to go figure out what you need there. It's one of those, if you look at the forums, it's kind of crusades. The default's 5. I don't recommend leaving it at that unless you've objectively proven that you need it at 5. However, some people out there make a blanket rule, set it at 50. Some say set it at 25. I always say be objective. If you do a quick Bingle search for Jonathan Cahias and execution plan tuning, he's actually got a really good query that'll help you pull these parallelism values out of the execution plan cache, and you can go see just at what threshold you're actually starting to parallelize this stuff. And then you can go do a sampling of those queries along with option maxed X. And you can go safely say, hey, do I need to raise this up? And does it actually help performance if I bump this threshold up a little bit? Now, I want to schedule the least amount possible on the widest number of CPUs that I can possibly get. The scheduling footprint of the hypervisor works better if you keep it small. If I can bump this number up just a little bit, and that means I'm scheduling less on the physical servers, the time slices inside the physical servers might actually mean that the entire server, the end performance might actually speed up. Again, there is no magic bullet here, there is no magic number. You have to do the due diligence to test this. But if you can test this properly, I can claim that these two numbers, when balanced properly, can make a big difference. Now, we've got the threshold there, the max degree of parallelism. We have the physical NUMA topology. We know that the memory lookup from another NUMA node is actually slow. If the VM is balanced properly there, I've now got max degree of parallelism. Well, what should that be set at? And again, there's no magic number in here. I mean, if you're SharePoint, well, sorry, you don't have parallelism. If you're other applications, you can actually take that number and adjust it. The fun part here is I like to do a starting point of the number of virtual cores in a single NUMA node. Now that's a starting point. Again, you can go test this. What if it's less than that? What if it's more than that? What if SQL Server can go balance this thing properly for your workload? But again, go test it. So set the VM to fit the physical machine. Set this. Watch this. Watch these numbers. If you can go through and tune these properly, it works. Now, the fun part here, it's not just a one-time thing. CPUs get added. What if these numbers need to change? Or what if a database gets added to that instance? Or what if a report gets added to the application? All of these different things change and they matter, and it's really interesting watching how the system changes. So I claim that you need to take a really good look at this number and the virtual CPU count of these VMs probably quarterly. If you're in a really busy environment, maybe monthly or every couple of months. Or if, conversely, if it doesn't change very much, maybe twice a year. But you need to go look at this stuff often. It's not a set and forget kind of thing. So if you can go set that, and if you get into the process of how to look at that and how to analyze it, cool. Now, there's a lot of really good third-party utilities that will help you collect this. You need to go understand how to get some of that data out so you can do your own analysis of it. And as long as you start working through that process, things are good. Now, SQL Server 2016 changes a lot of this. If you have a virtual NUMA node or physical NUMA node with with greater than 8 CPUs, SQL Server 2016 reserves the right to subdivide the NUMA node into soft NUMA nodes. Think about that. So now if my physical servers are, let's say, 2 by 15, I can build a VM here, let's say 2 by 14, so 28 virtual CPUs. Okay, SQL Server might come along and say, well, you've now got 4 NUMA nodes, each with 7 virtual cores. And it might actually start using it like that. And if you're not paying attention and you've got maxed op set to 14, well, you might actually be forcing SQL Server to start using more cores than it really wants to. And based on your workload, it might actually be slowing it down. Now, the fun part here is, what if this is subdividing it, and what if this is going to slow it down from it having to do that work? Again, this is workload specific. I don't know. I don't know what's better in your environment. But now, what if it's actually faster to reconfigure the VM for 4 by 7 instead of 2 by 14 and make it where SQL Server doesn't have to worry about soft NUMA? And by doing that, what if it's actually faster for your workload? So that's where all this comes full circle. So now you got to pay attention to the version and the intensity and the VM configuration and your workload characteristics and the physical machine topology. I don't want to say this is a very complicated problem, but it is, because now you have to go tune this, and we're talking 20, 30, 40, even I've seen up to an 80% performance improvement by setting these individual layers properly. It's not a quick thing, but it is a straightforward thing. So my bottom line for all this, test and retest and get into the habit of working with your VM admins to go test all of this, because this stuff matters. And if you can tell your boss that you can get a 50% performance improvement in your database servers in 10 clicks or less, and that you need a $10,000 raise for doing it, guess what? It might actually work in your favor there. So keep that in mind. If you're interested in this, this is just one small bit of the all-day presentation that we're going to do at the PASS Summit on how to really get the most performance out of your virtual SQL servers. What questions do you all have?
Well, David, we don't have any questions in the queue just yet, but I'm sure now that we've opened it up that some will flood in. The first one so far is just telling you that this is an awesome presentation, so great job there, David.
Awesome, thank you. Yeah, if anybody's got any questions, you know, CPU scheduling or honestly anything VM, we've got a few minutes.
All right, so the first question in here is, how do you convince your VM admin to allow you to, excuse me, read-only access to the hypervisor?
Pretty straightforward. One, there's two tactics. One is factual, one is emotional. The factual one is you need to know this impact. So the CPU scheduling queues especially, but you need to know what the host is doing. You need to be able to sample these processor queues, and you saw it's pretty straightforward to go get to and interpret. And if you can do that, you now have the ability to say, this thing is running optimally. If somebody reports a performance problem, you're not going to immediately blame the hypervisor. You now have the ability to go get that evidence for yourself. Now, the emotional side of it is, okay, VM admin, if you don't give me this, every single time I'm going to get a performance problem, I'm going to come to you, and it's now your job to go tell me this is not your problem. And you have to be factual and objective with this emotional request, because we're the DBA, we're the default blame acceptor. If there's a performance problem, we're going to go blame you, and now you're the default blame acceptor, not the DBA. And it sounds crazy, but in most cases I found that we've been pretty successful. You can also tell them this, that all these stats live in a database and you're the DBA and you can go mine it no matter what. And if they don't want to give you front-end access, well, email me and I'll give you the queries to go get all this out of the back end.
Excellent. We've got another question for you here, actually several of them. The next one up is from a person you may have heard of, Glenn Berry. He asked,
Yeah.
can you talk about the different layers of power management?
Oh my, yes. There are so many areas that I get into with the all-day pre-con. This one is very, very interesting. The physical servers want to save you power. There's a lot of different ways they can save you power inside the CPUs themselves. So a lot of times when you pull these physical servers out of the box, they're set to either balanced, which is meant to save you power most of the time, or operating system controlled. Now, in a lot of cases with general purpose VM clusters, leaving that at OS controlled is just fine. The hypervisor will throttle up the CPUs appropriately and everything's okay. For your big production database servers, I don't want to save power. I want the maximum possible performance total ever. So I will force the hardware to essentially run as fast as humanly possible all the time. It's not going to eat that much more power, but realistically you could be looking at a 20-30% performance improvement right there. When you jump into the hypervisor, you can now tell the hypervisor to not save power as well, and it's going to actually prevent the CPUs from slowing down. Then you get into the operating system, and Windows is trying to slow itself down too. And when Windows is trying to slow itself down and the physical server is trying to slow itself down, it's potentially bad. I mean, it's not good. So if you go into the control panel and just go to power profile, set it to high performance. You can do this through group policy. You can do this all over the place. And it basically just says, make this thing as fast as humanly possible. You're not going to have to worry about things jumping C states. You know, it's just going to stay as fast there as it can.
Also contribute that you can set those power policies with PowerShell.
Yes. I like to do it through policy personally, just so I don't have to worry about it. You tell the VM admins to keep that computer object in the right OU and all these things. You just don't have to worry about it.
If you have a domain.
That is true.
Quite a few more questions flooding in. I'll go with what is hopefully an easy one. Can you repeat the name of the source you cited for parallelism?
Yes, Jonathan Cahias over at SQL Skills. He's an awesome guy. The query engine keywords should be query, plan, parallelism, tuning, and it should float to the top.
All right, great. What tool do you use to test your VirtualBox for IOPS and latency?
For IOPS and latency, that's a storage discussion. That's a good one. There are two that I like to use. Well, Microsoft has deprecated SQL.io, or most of us should be familiar with that by now. I actually like to use disk speed. It's a new one from Microsoft. Now, it's not perfect. We're finding a handful of quirks with it, but it works really, really well most of the time. There's that one. There's also one that is kind of from an interesting company, Oracle. It's called VD Bench. It works really well as well. There's another one called FIO that we've been working with lately. They're interesting as well. Now, I would claim IOPS are not where you want to look. You want to look at latency. I make a lot of car analogies. Imagine this. You've got a beautiful Italian exotic car in the driveway, and you're putting around town, and the speedometer says you do 200. Okay, well, it'll go up to 200. Are you going to do 200 normally? Well, hopefully, but probably not. The flip side of that is, when was the last time you were at a light, and the light turned green, and you floored it to get up to the speed limit as fast as you could? The latency, the time it takes for the database engine to get to storage and back, that matters for every single transaction that you do. However, IOPS is kind of like that maximum value. Most of the time, the storage can deliver more IOPS than you need. So if it were me, I would focus on latency. If you can keep that latency down very low, then your database engine is going to be faster. It's going to max IOPS. A lot of you could actually drop the CPU count there. Now the fun part there is if you do this right, it helps you with licensing, which is a big deal. It also helps you with the back-end performance like we just saw. Ideally, I'd like to see my virtual CPUs in the 40 to 50% range normally. I don't want to see them get too much more than that because it means you don't have enough headroom there for burst capacity. But if you can keep it active but not really busy, then you're doing good. Honestly, I don't know of one.
I know of one, Excel.
Yeah, that honestly, either Excel or some custom scripting that we've got, as part of our consulting. But I don't know of any commercial third-party utilities that will automatically tell you max stop out there. You basically need to sample performance and run it through whatever mechanism you've got to go see how you're doing.
Next question, similar topic. Good stuff, David. Can you say a bit more about max stop and how to test it in a virtual environment?
Yeah, well, max stop and how to test in a virtual environment. That one is interesting. Max stop essentially means I want to tell SQL Server to parallelize up to when it parallelizes a query, it'll use up to that number of CPUs to try to execute it on. The interesting thing there is if you have access into the hypervisor, you can actually tell what logical cores inside the VM that SQL Server is using for something that's very active and busy. You can see it through perfmon. If you can see that, you can match those virtual cores inside the guest with the virtual core number at the hypervisor, and you can watch where those things are getting executed. Some hypervisors out there have a back-end ability for you to go see what NUMA node those virtual cores are running on. It's not an easy process to go do this. It is a manual process, at least right now. And if you can do this, you can pair those up properly. The good thing is modern hypervisors, and VMware and Hyper-V are definitely included in that list. If you set up the NUMA nodes properly at the VM level, there is a really good chance that's going to get executed just like you configured it on the physical NUMA nodes on that machine. Rarely does it ever deviate there, and if it does, it's because there's just too much going on in the background and it just can't get enough scheduling time there. So if you can get access, you can piece the pieces together and go see it pretty comfortably.
All right, great. Next question. What exactly do you pay attention to when you test different configs? I'm using DR replay with prod workload. I was comparing elapsed time, CPU, and I/O stats during my different config runs. So
yeah.
What do you pay attention to, David?
Yeah, that's really the big stuff right there. I mean, the elapsed runtime is great. I mean, if you run distributed replay in stress mode, you'll be able to get that end runtime. If the end runtime is improved after you make a change to the VM, great. Then overall, you did better. Now, individual processes may suffer, but the end result was better. So what I would want to do is I would want to look at individual query runtime before and after to see what changed for better or for worse. CPU consumption is a big one, but if you run it in stress mode, it's probably going to max the thing out. Disk activity is good. Now, I would also replay it in real-time mode, and then you can watch the CPU consumption there per query. If the CPU consumption there is lower, then whatever you just did made an improvement to the overall consumption. Again, you got to put the pieces together, but I mean, CPU stats from everything from just core consumption, frequency if you don't have the power settings set, the number of times it jumps, C states, all of those different things. If you look at the wait stats inside SQL Server to see if those change, that layer will help you. Memory, basically pages read and written to per second. If you're swapping, you may want to look at that. Disk activity, definitely with latency query, number of reads and writes per query, tempdb activity, all of these different things. It depends on your workload for what I'm looking at. Query runtimes, individual query runtimes, overall elapsed time differences, CPU consumption, and disk activity.
All right, we've got almost a full page of questions to throw at you. One more comment, excellent presentation. Next one, trying to go for some of the quicker ones. Do you have on your blog how to check the power management?
I should, and if I don't, I will. Let me make a note, and I'll put that out there today.
Let's see. Here's a good question. Is it possible to use VMs created with VMware Workstation on a laptop to learn these concepts?
Absolutely. Absolutely. You don't have to have a crazy home lab that draws too much power. Not like I'm talking from experience there. You don't have to have any of that in order to go test this. If you've got a decent workstation with a decent amount of RAM and maybe a moderate SSD, even a laptop will work just fine to go test and evaluate a lot of those.
All right. So here's another one. You mentioned the CPU clock ticking 64 times per second and how there is overhead for a VM where it can throw off performance counters. Would you please explain the reason for this again?
Yeah, the reason for that is the hypervisor, if it is struggling to keep up with the CPU clock ticks, meaning the amount of time spent scheduling is high, the hypervisor won't jump time. It can't. It shouldn't. I had a long time ago, I worked at a hospital, and if we jumped time, we might actually miss the trigger for pill dispensing, which would not be good at all. So what the hypervisor has to do is it'll lose a little bit of time based on CPU scheduling, and then it'll actually have to kind of accelerate time inside the VM to get it back. Now, it'll jump, it'll skip. If Active Directory is not keeping up fast enough, Active Directory can actually resync the time. The hypervisor can kind of dial stuff back and forward with the speed of time. And if you do that, the amount of stuff measured in that time slice, the physical time slice may be bigger than what the VM is consuming, so it can skew those things. And the worse the scheduling impact is, the greater the potential for skew at the hypervisor is. And the biggest areas that I see it is honestly CPU consumption and disk latency metrics.
All right. Next question. New counters to look at in Windows Server 2016.
TBD. I don't talk too much about that until we hit RTM, whenever that is.
Yeah, whenever that is.
Yep.
Probably soon,
Hopefully.
Yeah, there's a good opportunity at an event in Atlanta coming up. Who knows? Maybe they'll do it then. Sorry, I'm going to jump back with the power to actually help answer that power question. I got one from the Tiger team that I'll get to. Another question for you. Would you mix SQL Server and app servers on the same VM host or separate?
Great question. I always throw this back to your licensing. If you are licensing based on physical core, there's a good chance I'm going to try to not mix them because I don't want to consume resources on non-SQL Server workloads that you've just paid a lot of money for licensing. That said, if you don't have a choice, as long as the workloads are complementary, meaning most things are not super CPU intensive, they might be disk intensive, and if you've got a SQL Server that's properly built, it probably won't compete that much. But you just got to be very careful. You can go see the impact of one on the others inside the hypervisor layer. So, as long as the SQL servers get priority to the resources, and you can do this through resource pools, you probably are okay, but you need to keep that in mind.
All right.
These are great questions, everybody. If you're interested, please come to my pre-con because I'm not kidding. I will not leave that room until all your questions are answered.
All right, we've got a lot of, congrats, this is a great session, thank you, things like that. You can read those later.
Awesome. Thank you, everybody.
Azure SQL perspective, to what degree taking care of my MS engineers? I'll assign that question to you to see if you can figure out how to parse it.
Yeah.
Is it read?
Long story short, if you're doing Azure VMs, you do need to try to pay attention to this. It's not as easy, it's not as straightforward because you don't get to a lot of the back-end stats, but you do need to keep this in mind. If it's an Azure SQL DB, you probably can't do anything about this, but just keep that in mind.
All right, good to know. Folks, we do have time for a couple more questions, maybe one or two. Here's one. Our company is moving to VMs for most new SQL servers. What size server would you say would be too large for virtualization, specifically for a reporting application? And also, can you speak to VM performance on SSAS and SSRS standalone servers?
Well, the performance on the standalone servers, if you can do it in physical, you can do it in virtual. I claim that modern hypervisors, and all of them are included, are less than a 2% overhead. So I would virtualize everything. Now, how big is too big? I mean, what's the maximums of the platform you're on? I mean, the biggest you can do right now, what did they just announce? 512 cores on Hyper-V 2016? I mean, that's awesome.
All right, and then we've got a question here from Glenn. What are your opinions about enabling hyperthreading on the host?
Ooh, that's a good one. Enabling hyperthreading on the host, it's another one of those, it depends, and you need to test it. And most of the time, the hypervisors are going to try to avoid the hyperthreaded cores. However, there's overrides that you can go set to fix that. And if the workload is such where the hyperthreading is fairly balanced, it would actually make sense to enable it to keep the NUMA locality on one NUMA node. And you'll actually find that in a lot of cases, you get better performance that way. But again, you got to test it to make sure it works for you.
All right. How much of the hypervisor's CPU clock speed is going through to the VM guest / can be used utilized by the VM guest?
On average, greater than 99.5%.
Yeah, it's really gotten up there.
Yeah, it's very efficient.
Yep. Just a comment about the SQL Server doesn't monitor in virtual file stats. I mean, it's got wait stats. So.
And it's got waits on disk stall. If you hit my company site, heraflux.com, I've actually got a collector out there that can help you identify latency by database data files. You can actually use that and overlay that with perfmon and go see more of what's going on.
All right, and just more congrats in there. One last thing, and then we'll close it out, is the question was just saying, are you using ESX top? And I think that was a follow-up to that last question about the latency.
Yeah, that one is VMware specific. I can go into detail in person at the PASS Summit on that one. I don't want to bore people with something specific to a platform. If you can get access to it, it's an incredibly powerful tool. But again, hit me up at the summit and we'll do a deep dive on that.
All right. Thanks so much, David. Thanks for everyone for joining us for this 24 hours of PASS. There's another session that's going live right now, so we're going to go ahead and end out of this one. But don't forget that you can sign up for the PASS Summit with the discount code, taking $200 off. And I believe that's 24HOP200 for the discount code. Thank you so much, and follow along on Twitter, PASS24HOP, or with the exact same hashtag PASS24HOP and SQL Pass.
Awesome.
Great job, David.
Thank you. Thanks, everybody, for getting up this early and attending. I really appreciate it.
All right. Have a great day, David.
Thank you. Thanks, everybody. Bye now.